Okay. Um, Hello everyone, and thank you, Anita, to introduce me so nicely. And I'm a soils guy, so I'll try my best to make my presentation towards irrigation and water scenarios. And like you can see, uh, I'll be talking about cover crops, and you know we know any crop will need water, and cover crops will also need water. So I'm going to talk about certain different ways how you can use cover crops to get benefits out of it, and still, you know, utilize your water resource efficiently. So, um, there is a mechanical part there, which is irrigation system, what method you use, how much water to use, how frequently to use. And there are great presentations, and already Dia spoke, Russ spoke about many other objectives. Um, I will talk about how you can kind of help water move through your system. When I'm talking about system, I'm talking about the atmosphere above ground, the crops above ground, and the soil and other things below ground, including living and non-living things. So there are some numbers here. USDA, NRCS, they have been looking into how much water you can save if you can improve your soil health, you know. And one of the factors that we look into is soil organic matter. Now, we're in a desert and we do not really have very high soil organic matter, but it's not about how much soil organic matter you have. It's about what you had and what you have now and where you can be in the future. So because it's all relative, right? We are in an environment, we have abundant sunlight, and we can grow a crop all over the year. Some areas with higher soil organic matter, they may not have these opportunities. We do have. So there are always trade-offs. What I'm trying to say today is, can we build soil organic matter in our system in desert, different elevations, different cropping systems, different expectations? Um, that's what my goal is. I want to create a soil that can store more water and reserve more water, because soil has particles that can hold water, and soil have pore spaces that can hold water. So as you can see in the I don't let me put a laser pointer. So as you can see in this picture, uh, different kind of spaces in between soil particles that help water move through it, and that also help water to store water. You need a nice balance of both larger pores and smaller pores. Um, and this is a perfect structure because you can see the water can move easily. Here, water is kind of stuck somewhere, it's ponded. So, a healthier soil have should provide enough channels and pathways for water to move freely, also to store water. Let's not go deep into soil health because that's not our topic today. But let me tell you what soil health actually says. It says a soil that functions well is a healthy soil, and one of those functions are providing water to the crop and storing more water, reserving more water. And a healthy soil should preserve more water. Also, this is very important to see, and we all know this, like how important carbon is. And when I said soil organic matter, a large portion of that soil organic matter is actually soil carbon. Um, Organic carbon. You can argue that the caliche we see, that's also carbonate, right? That's also carbon, but that's not organic carbon. That's inorganic carbon. It's the chemically bond carbon, and that is of less use. I will not say no use. It still traps a lot of carbon dioxide, but it is not helpful for agricultural systems. It's a crystal hard substance in the soil that put a lot of barrier in your production. So we're talking about soil carbon that is organic. So organic carbon is very important. And because it helps you store nutrients, store water, because what carbon does, it creates structures or like look here, right? And you can see there are so many um pore spaces there, like smaller pore spaces that can hold water for longer time. There are nice aggregated systems. The particles are nicely aggregated. There is a gel in between, which create a nice structure for water to move and to be preserved in the soil. Organic carbon helps in making this segregation. It helps attract nutrients. It helps attract because there is a electrostatic attraction. There are bonds going on. There are sites that are charged positively and negatively in the soil, and organic matter, organic carbon based matter, they can create more holding sites inside the soil that can hold more water along with more nutrients. So that's why carbon and overall organic matter is so important for our soils and for uh, to maintain a healthy soil that will preserve more moisture too. Now, if I think I'm not going to discuss about any irrigation related matter, but let me tell you this, like we probably all know that what are the main areas where you can conserve water in the desert. You need to have a better irrigation system. Then you have to find a way how you can prevent water loss. Like Rush showed that Russ was showing that some people are using some kind of protective cover on top of their drip system to reduce transpiration and evaporation. And together it's called evapotranspiration. It's the loss of water from our soils. So we have to find ways to protect this loss and conserve more moisture. Then the next thing is we have to grow something that is water wise and reduce and use or overall over if you budget annually, it will use less water compared to other crops. And you call it water wise, water smart crops. And here is a photo of Wioli, which is a desert crop, and we're currently working with it. I'm not saying Wioli is the only crop. I'm saying it's one of the water wise crop. It doesn't die when you don't have enough water or sufficient water. It comes back when you irrigate them. There are a lot of varieties. There are a lot of varieties that we use around the state. There are a lot of crops we use around the state. I know Michael. He uses some specific corn cultivars that can thrive a lot more moisture stress, or that can grow with a lot less water. Well, our planting type and everything will be different, but we need to think about these crops that would survive in case you don't have enough water. And the last point, I literally think it's kind of bottom of the priority list for water conservation, but it's an important thing, like building your soils and building healthy soils, having more carbon and storing more water. And do not compare this photo with our soils. This is from a different environment. This photo is actually from me. I got this photo, but not from Arizona, from another place. I wanted to show, like, um, if your soil has enough carbon, it can store more moisture. Now, come back to cover crops. In a general sense, I think there is an understanding when people think a cover crop is just to protect the soil and it should be incorporated into the soil to build carbon in the soil, and in the meantime it can create you know biodiversity, a more diverse system, because as you can see here, you have a lot of different crop species growing together. And some people can call it, oh, it's a weedy field. Well, it is. Weedy field is a very diverse system. But that is not really desired because it's hard to control. So we when you say cover crop, it's a managed cropping system. So you can manage the cover crop the way you want it. What is your purpose for this cover crop? So, cover crops can be used in different ways. Some people use legume cover crops that can fix nitrogen. Some people want to graze them. And definitely boosting soil biology because these crops, compared to a fallow system, these crops can provide food for the microbes in the soil because when you have a growing crop, a living crop, it can take carbon dioxide from atmosphere and photosynthesize using sunlight and carbon dioxide and water, and then it feeds through its root system to the below ground soil. So there are multi level of functionality or benefits of doing cover crops. But here I'm going to talk about certain cover crops, and there are other benefits like we can, definitely control weeds because if you don't have anything growing, something will grow there if there is resource, there is water, there is carbon, something will grow. Um, Also, so for this perspective, for this presentation today, I'm going to talk about cover crops from soil conservation side, right? Now, it is very clear that more the roots there will be more channels, there will be more infiltration of water. So if you have off-season precipitation and you are in an area where it is hard to get water from other sources, and whatever water you get is good. I mean, anything is good when you have you are stressed with moisture. More roots will create more channels and preserve more water. It's kind of easy to see, and this diagram can show like how these channels are created or the pore spaces are created and how you can preserve water with having more roots in the system. And also compared to bare soil, uh, in a soil when there is nothing to utilize these sources, you lose whatever carbon you have, it will be exhausted, it will become carbon dioxide and go to atmosphere. You will lose your topsoil through erosion, and if you ever receive any rainfall or something, you won't be able to catch it. And cover crops can do all of this. It will prevent erosion. You can put channels, root channels, and system which has more infiltration capacity in the soil, and it can also trap carbon dioxide. So it's a carbon sequestration way. Um, Here in Arizona, we are very restricted with what water we have. So I've been thinking how we can reduce bare grounds, because if you keep a ground bare, it's very hard when you come back and try to farm that ground again because there will be a lot of salts, there will be a lot more eroded soil, degraded soil. It is hard to make it fertile again. And in a year, when you have and you try to cultivate it again. So I'm kind of, we don't want to lose our mineral rich soils. So I want to put a protective cover and reduce that. And that's why I've been thinking how we can use cover crop that would utilize a very little water and can fit into the water budget. Like I understand sometimes what happens that you don't have enough water to, put a crop everywhere, all the land you own or operate on. Um, my idea of this cover cropping is, what if we find an opportunity where you can cover this ground with like drastically less amount of water, um, and have something out of it. And when I say something, I was talking about definitely water storage, but we get too less precipitation. Our water storage will never be significant, but we can grow a crop with that. So we can grow a cover crop with the little water we get through precipitation. But my area is where I'm looking into is kind of putting as a livestock feed. Can be through grazing, and in a nice future, it can be like a salad mix for like the livestock industry, where we grow a multi-species plant as cover crop with a very much less water compared to the traditional hay or forage crops. And this will be interesting because the nutrition quality and the biomass we can produce and the water it uses in all three areas we can kind of trump the existing traditional hay forage systems, along with other benefits, soil health benefits, weed suppression benefits. Okay, now, while our challenge is water, we don't have suitable crops to grow as cover crops here. Um, if we look at what other states use, I don't know why it is showing thumbs up. Okay, I don't know. Anyways, uh, so so we don't have suitable crop or enough suitable crop that can grow in arid region because of the salt, because of the stress from from the heat, the sun, especially in the summer. Um, because if you grow some winter vegetables or winter cash crop, you need a cover crop in the summer when it's very hard to grow anything. Uh, so there is a challenge there, and we talked about the heat and drought stress. Many crop will just die and not come back. And then salts, another thing that I mentioned, that will resist germination of certain plant species. So it is very hard to find the right cover crop, and that's why many growers they say we grow cover crops, but ultimately they are probably using a single species cover crop, which is not wrong, but it's not really cover crop if you cannot provide multiple benefits of cover crop through the system. Now, we can argue on that all day, but the idea is I want to create a cover cropping system or cover cropping, let's say, mix that will have multiple benefits, not just protecting the ground or just feeding the biology. We'd have like diversity, water conservation, or low water use, and carbon buildup, and nitrogen fixation, and all those things. So first, I thought about what about we do some grazing cover crops because we need to graze, and we have a pretty big industry that uh, that has cattle here, and from that point of view, I started thinking about, okay, if we have some cover crops during the off season when either the forage crop is high or the price of forage crop is high, or if you have to buy from anywhere else, what would happen if we can grow again all the cover crop I'm playing with. They're utilizing very little water. I'll give you a number very soon, but they're utilizing very little water. So I was thinking, can we catch off season precipitation? So what time should I plant, what time should I, how long should I grow, when how long should we graze, and everything. So this is the ongoing project that we are doing right now. But the idea is, one way we can do it is in the grazing lands where people are required to graze, and we can grow some cover crops to include more diversity first, because they're probably in many systems I have looked into, they probably have one or two species. So I'm kind of introducing more species that can grow here, and overall, when you add multiple species together, there is a inherent competition that happens between plants, and one plant pushes each other. It's like it's a competition that is in every living beings. They compete for resources so that they try to take more space, more sunlight, and they push each other, they grow each other. I have seen alfalfa growing with rye, and just beside that only alfalfa growing. The flush of both of those crops will be so different, and I figured that it actually worked, and growers told me that it actually worked for them. So that was the first area. So instead of just two, what if I do three or four or five different mixes, all different class or of different categories of plant. So one is maybe something like mustard or canola or rapeseed, or something like a legume, like a bean or vetch or clover, something like, or alfalfa is also a legume. Then some grasses, some of them like maybe, I don't know, radishes, or that can break some compaction. So I've been mixing too many things and trying out, because that's potentially low water use, and I was definitely picking up the low water use, like drought resistance varieties and species. And again, it can be perennial or annual. And if I'm looking for perennial, I'm thinking, well, what if we don't have any water for a long period of time? Will they die? And then how fast they can come back and produce something? So all these considerations, and we have been looking on some annual. This is not the comprehensive list. This is just examples what we're looking into. Some annual, and you can see oats, ryegrass, and sorghum Sudan, they are grasses, while the crimson clover is a legume that can fix nitrogen. The carbon trapping capacity of these crops are different. As you can see, the biomass they produce. The more biomass they produce, they would require potentially more water because the biomass is a factor of water and carbon dioxide and sunlight. Now we have plenty of carbon dioxide and sunlight. We don't have plenty of water. So, the biomass you produce will be directly proportional to how much water you put. Um, and you can use any irrigation system and any the best method, but if you want to grow crop, if you want to grow biomass, you need more water. That's it. I said that. And perennials, some perennials, I didn't use all of them. These are kind of still in an exploratory area, so I cannot show data from these perennial crops because your data requires some time. And uh, so when I'm talking about alfalfa, I'm talking about the best quality alfalfa that you generally use for hay production. I'm talking about, like, probably medium to low category alfalfa, because it will be not be our cash crop per se. It will be our secondary forage crop. I'm looking at it, and kind of a nice mix of grass and legumes together, right? Now, here's a slide to kind of compare how much water we're using for different crops. Now, the numbers may vary. Don't pick me into it. Don't please don't take these numbers to heart. Because these numbers may vary depending on what kind of systems you are in, what elevation you are in, what part of the state you are in, and what kind of management practices you have. But on average, this is kind of the numbers I kind of found from different conversations and something. But with the number, like how much water you were using for one crop, these are all annual crop. I also put how long they're in the field, okay? Because that is very important, because a crop like alfalfa is there in, thinking about central Arizona, or in a lower elevation with the warmer environment, you can get up to 12 or 14 cuts, that 12 or 14 harvest, right? So it would require a lot more water. And compared to other places, like, I have people I work with in Minnesota, or near Minneapolis area, even in South Dakota, they only get two cuts, maximum three cuts in a good year. But South Dakota, they don't go three. But even in New Mexico, northern New Mexico, I have people in Farmington area, and they get two to three cuts. So I was like, okay, now you know why they require less water than us. We are producing a lot more food. We are producing a lot more hay crop, and that's what matters. So what matters is how long you are growing that crop, what season you are growing the crop. Definitely, if you are growing something in the summer, you will be utilizing a lot more water, because it has a additional evaporation pool. So it will take a lot more water just for evaporation, or just to cool down the plants through transpiration. So evapotranspiration demand is higher in summer. It's pretty straightforward, right? But when you look at the numbers and you want to pick some crops that are bad or good for our state, or our production system, we cannot really pick into what total amount of water they're taking, but we need to consider when they grow, how long they grow, what is the money I'm coming out of it, and how many production, or how many produce we can get out of it, right? Um, so, like I said, biomass is a crop biomass is completely proportional to, how much water you can use. So we started looking at different mixes, and I deployed my team. We started measuring. Mostly, we are a soil health lab, so mostly we were measuring the soil health part of it, like how we're improving the soil. But secondly, my other intention was the forage part of it. So I've been looking into forage quality, and I will show you some data. And we have been looking into different species, because you can see all these are looking a little different, because what time of the year that we were growing them, and following what crop we are growing them. That is kind of regulating what kind of cover crop mixes we are using, forage cover crop mixes we are using. And in the last 2 years, 2022 and 2023, these are the different cover crop species that we used for mix. Now, this photo, as you can see sheep grazing on it, it's not from Arizona. This is from Northern California near Davis area. I was attending a workshop and they showed me this, and I can find some photos from Arizona. It's just probably the better resolution photo I have. But there are places in Arizona where people do graze with sheep and goats on cover crops. Those cover crops don't look this lushy, maybe, um, because we don't get as much rain, as much water. Um, but yeah, we tried growing all these different crops and successfully grown most of them. Depend, but not all these species grown in the same what I can say same study site. So these are all done in mostly in producer farms, and we started some research in our Marigold Pack Center. Um, but most of these are producer farms, so depending on where they are, what kind of salt problem they have, and what kind of challenges they have, like how like at what depth they find the first caliche layers and stuff like that. That will dictate what kind of cover crops would be successful in there. So I do work with people and help them custom design. We work with the cover crop seed vendor, and we can create a mix, whatever the need or the goal of that farm is, and that's how we decide. But so overall, this many species we can grow under the right environment in Arizona, and there are more actually, but I did not try all of them. Um, Let me explain this slide a little bit. So you see the summer and fall. Fall means it's generally going after wheat or some kind of spring or summer crop. Maybe sometimes after corn. People grow a lot of corn here in this area for even for silage, green chop, and all those things. There are a fair bit of people growing other grasses too, other hay too. So this fall cover crop is going after that summer crop, maybe after sorghum or sometimes Sudan grass. Um, and summer cover crop is uh, going after a spring winter crop like wheat, you know. Um, there are different sites. Don't worry about where they are. They're all around the state, not from one place. What I'm doing, as you can see, the numbers, it says 100% BL, 130% GR, 70% BL. Now, let me tell you this. So, GR is grass and BL is a broadleaf. So I categorize the species of this crops into grasses versus broadleaves, which are not grasses, are all broadleaves, like alfalfa broadleaf, clover broadleaf, canola broadleaf, you know, and grasses like ryegrass, oats, barley, wheat, sorghum Sudan. They're all grasses. So I'm mixing different proportion of these grasses and broadleaves, and the reason being, the more grasses you have, you would create a biomass with higher carbon than nitrogen in the system. So you would produce a biomass with higher carbon, you would require to trap more carbon dioxide, and then when you do that, you would require a lot more water. So a higher if we have the similar seed rate for all this which I had during every season, and the higher the grass, you will probably have more water taken. But what I did, as you can see these numbers here, let me, uh, so these numbers here, as you can see, I, it's in the same field. So we could not produce different levels because it's a grower field. We did not have the capacity to irrigate them separately. So we tried to irrigate the least possible way. And so I'll explain. I'll go there. But right now, as you can see, there are different levels of grasses and broadleaves we are mixing to see what works better. The idea is to reach or kind of be comparable to this level. So this is the alfalfa and barley hay data for all forage quality: crude protein, total digestible nutrients, relative feed value, and relative forage quality, biomass, water use. Now, for alfalfa, the biomass is a lot higher. Even sometimes we get, this is the average, 8.2 or something this year, last year maybe. There are 11. tons per acre alfalfa in our state, but it's coming from 12 different cuts. Okay, so the idea is we grow some biomass enough. So now here you see we don't have data because it was the initial study, so we didn't have enough resource to do all this, so we couldn't get a biomass data. But then we started measuring biomass data, and we see we get a good biomass, good amount of biomass, and we are using a lot less seed rate. We are using so because we are trying to grow a forage kind of crop with higher forage quality for higher forage quality, we are using a higher seed rate than natural cover crop seed rates that are kind of recommended by NRCS or other papers or other published literature. They're using a lot less seed rate than what we used because our intention was we cannot use that less seed rate because our idea is to grow a secondary crop for the growers so that they can graze or maybe in a good year they can sell when there is a need of hay. They can sell this hay if we have a good quality hay there, and that's why we're using around like 65 to 70 pounds per acre. um like generally cover crops are below 40 or 35 pounds per acre seed rate. We're using a little like double, literally the double seed rate we're using to achieve more biomass. But if we don't utilize a lot of water and we can access some of the late season, I mean, when I say late season, I mean the cooler season rainfall, like off monsoon rainfall, um, then we are good, right? And we are just making it, giving them enough because seed is not that expensive compared to the produce. So um, that's what we're looking into, and see the numbers are pretty close to the numbers we're trying to reach. And these are average. These are average from different publications we found. Some of these publications are actually from Arizona, but when you do, and most of them, these numbers are um, also kind of research level data because I didn't have access to the dairies, like what they buy actually. Um, but these are research level data. So for research level, sometimes the numbers are under or overestimated depending on, you probably use a smaller scale, you probably have a better control on things. But long story short, the numbers are pretty promising. That's what we found, and it's not one or three. So it looks like it's the eighth side, but it is a lot more than that. I just averaged it out because I just wanted to keep my partners, my collaborators anonymous. But idea is that is we're averaging things out, and we see a pretty good number on forage quality. Why is that? Because we're a diverse crop. We have a lot more legumes and everything in the system. It adds the nitrogen, which is not a lot that would burn a feed. Like you don't. That's like it's not that hot. Not no, not so high in nitrogen that would be troublesome. It's nicely balanced, and you can kind of play with the ratio depending on what kind of cattle you have or what kind of other smaller livestock you have. So yeah, that's the game here. You have to figure out what works for you, and we have a lot more options. You just pick, like you're growing a salad rather than buying like later scale spinach separately. That's the idea. That's how I try to convey this message. And this is what we grew at Mac last summer. Um, so we used 12 inches of irrigation water, three irrigations, so one 3, 1 4, 1 5 inches irrigation. So we started with one, and we grew it for 2.5 months, 10 to 12 weeks, 11 weeks, I guess. The crops you're seeing, which is more dominant, they're like sorghum and other millets. Like this, these are millets. And if you look closely, you'll find like yellow flowers like this. These are sun hemp that grew very tall and very good biomass. Now, I I I have photos, but there are smaller cover crops that could not really compete with these crops, just because this grew faster, probably because of the variety. And this is kind of exploratory research happening at the Maricopa Ag Center, and this is my truck. So you can see how high they are. how tall they grew with only 1 feet. And we had a workshop back then, and producers didn't believe. I had no way to let them believe. But yeah, we only use three irrigations, and these are only 350 feet runs. So I literally did not put a lot of water. One in the beginning after the seed drill. After we drilled the seed, we did one irrigation, which is a little like three point something. And then we did a four, and the 2 or 3 weeks after, and then we did a 5 inch irrigation, little in the middle of the summer. We probably grew during July, August, and September. So we went in early part of July, actually, when it is not hot enough, probably 105, 106. Yeah. And then we were working with one grower in the valley near Glendale, Peoria area, and he had a cover crop. Sorry, not cover crop, an alfalfa like this. It was a 4-year-old alfalfa stand that we took some photos, and he said, "Can we do something with it? Because the growth is so little, you cannot really harvest it. So it's a lost cause. It's a lost resource that the growers cannot do anything. It's there, it's occupying the field, and he really is not ready because it's not ready to. It's probably in December when we took this photo, and he was not ready to, get rid of this, grow something else. So I was like, okay, let's put some cover crops in. So we went there and we had to scrape the topsoil a little bit because it was hard as hell. Um, we put some cover crops in, and this photo, the second photo, is around January second week when, and he only used one irrigation in the whole scenario. So all the photos you will see is just one irrigation, not a more. But he did irrigate a lot, 6 inches or 7 inches in one go, and that happened after this photo was taken. So we got some late season rainfall in the December, January. I don't remember how much, but that area got a little bit, like couple of inches, and we saw some germination. It was not coming up, so I said, okay, go ahead and irrigate. Um, and he did irrigate, and this is from February third week, around 20th of February. And this is what we're seeing. Well, most of it is still alfalfa, but we believe that these other crops that we put in, mostly grasses, that kind of pushed alfalfa to grow. There was no further irrigation. Well, during just before this photo, there was a little rainfall, like another 2 inches maybe. So there were some couple of rainfall, maybe total 4 or 5 inches of rainfall. So still, it is less than 12 inches actually, like around 10 inches of total water that received. But if you did not have this, you probably wouldn't be receiving that precipitation. That would have been lost some different ways. And this is the from March, uh, when he decided, okay, we have some, and I think after a couple of weeks after this, he could go in and harvest. Not a lot, but still something that he can bail and get some money out of it. So I think he got around a ton, less than a ton, like 800. Sorry, not 800. I'm thinking hectare. So it's like zero point 0.8 ton, let's say, less than just shy of a ton per acre. Uh, so like 15, 1,600 pounds per acre or something like that. So yeah, that's what he got within 3 months with just one irrigation, because he could catch those 4 or 5 inches of rain that he wouldn't have caught otherwise, hopefully. Uh, the problem is we don't have a control there. So we don't know if we didn't put it, what would have happened. Well, we have some data from the side borders. He grew some outside that field, but we don't have the data to show yet. We are still processing the data. Um, Another thing is, if you want to grow some trees, perennial trees, um, either like, I think this is pecans. Um, you can grow cover crops in middle and integrate livestock and kind of have an agroforestry system, which is which is a very, very regenerative system nowadays. And you can see the growth is not great. I mean, I don't know what is the average size of a head per operation. I don't have that data, but this operation is it's a 60-acre area. They had like 10, 12, 15-ish head, not a lot there, but they had a lot more goats too. So they don't need a lot of forage, and they have this system that they built. They move the cattle and they graze, in the shed of pecans and stuff. So it's a pretty neat system. It's not a research system. I have seen this in the Benson area, south of our state. Um, and some more ideas. These are all photos that some people are doing. I don't have research going on. We will be starting research on vineyard, this vineyard, particular vineyard, this, I mean, this season, coming March. So we'll be putting some cover crops there. I don't know if it is visible or not, but there are cover crops here. And here you can see there are different styles. Sometimes you can put some cover crops in the row, sometimes you keep it clean, depending on what is your goal, what you can do, what you can achieve, what kind of equipment you have, what you can rent, or there are so many things to consider. But we can custom design cover crops, low water use cover crops, and hold more moisture and conserve and get some benefit out of it, forage benefit. uh, and we can manage the soil better. Thanks. This is the field. This is the workshop we had, and now you can see a lot more yellow flowers from sun hemp. The same field from other side. Uh, I'll stop here, and if you have any question, I would love to answer.
Thanks, Debunker. This is really awesome. Does anybody have any questions?
Hi, Anita. It's Jan again.
Hey, go ahead.
Hey, I had a question.
Hmm.
For East Central Arizona, what kind of low water use cover crops could you recommend?
What you generally see around you? Can I ask you a like alternative question first before I answer this? Like, what do you see growing around you? Like, what crops do you see? I mean, not cover
Um,
crop, but yeah, go ahead. Sorry.
like alfalfa a lot of times.
Uh-huh. What other hay do you see?
Hmm.
Do you see
Like
other grass-based hay like millets, sorghum, Sudan? Sudan will require a
sorghum,
lot. Sorghum, you
yes, sorghum sudan, maybe some oats.
oats, right? So now you have your cover crop here. All you have to do is mix them together. All the cover crops I'm using, except for the clovers and wedges, which I use only on a couple of scenarios. And this
Okay.
sun hemp is pretty hardy crop for summer, especially. So the idea is you grow these crops in different fields, just to bring it to into single field. What it will do is reduce the need for a particular species down. So if you had all alfalfa versus you have 1/5 of alfalfa and rest is something else, it reduced the requirement of water of that crop. Also, by competition, it will force them utilize the little kind resource they get more efficiently. That's just
Okay.
evolution, let's say. That's how living systems work. When you stress something, they try their best to make maximum out of it, or they bail out. But generally, what I've seen, if you find like at what level you can put the stress, you can really kind of get benefit out of it. And it's a concept of like some people call it, a deficit irrigation concept. Like, we know we will lose the yield, but we'll still do. I mean, if we cut down 50% water, we should not lose more than 50% yield. Then still we are good. Like that kind of scenario. So what we are doing, we're growing the same crops, but together. So overall, it is requiring less water than the most thirsty crop in that mix,
Okay.
and giving you a nice biomass, through competition and everything. So if you can just do oats, so oats is good, barley is good, nice drought tolerant. Sorghum Sudan grass is a very good, very dominant. So you have to keep the number of those seeds less, as less as possible, because if you have more, it will cover everything up. Then you can do for summer like cowpeas, or there are other crops like bale beans, and bale beans will work if you don't have too much salt. I don't know what is your pH and everything, but yeah, I mean, these are some crops that you can grow. But it's literally what you see around you. Just put them together, and and which crop is more, what I can say, more resource user. Keep their
Okay.
proportion to a lower proportion. Just
Okay.
have them in lower quantities in that mix. That's how you know.
Okay.
But if you can if you reach out to me,
Yeah.
I can help you. If you tell me what exactly you need, what is your purpose, and if you have any soil or any taste report, or you have any idea about the soil, I'll definitely help you on that.
Okay, great. That sounds really good. And yes, I will, because I've got one of my producers in the past, they grew
Hmm.
sorghum, Sudan grass,
Hmm.
and cereal rye in a mix, and they were doing that basically they had a lot of weed competition, and they were
Right.
trying to transition over
Uh-huh.
to organic. So we recommended that mix, and
Mm.
and I know we're all trying to use less water.
Uh-huh. Was it a Bermuda field or Bermuda grass invasion in the weed, or just all kinds of weeds?
It was I know the one that kind of stood out was Devil's Claw.
Devil's
They had
Claw. Okay.
a very serious weed problem, and from what I
Right.
understand, they still do. And I've got to visit with them in a couple weeks to see what we can help them out with. But yeah, I would definitely like to talk to you more about it and kind of give
Sure.
you this area I'm working at. I appreciate that very much.
And I mean, if you really want to read some more details about some of my existing publication, I can share, or you can just find like the Bankur Sanyal cover crop. You will find something online, I think. They're
Okay,
not many
great.
the Bankur.